Hi. So thank you, Tom, for leaving me with that to follow. Much appreciated. It's very good. So my name is Richard Marshall. I'm another head of platform from Wealth Wizards. We're based up in Leamington in the Midlands, so I've braved the half an hour of snow to get here. I hope you all appreciate the long journey. So we spent about 18 months now working with kube, containers and microservices, and I just wanted to share a little bit of what we found over those 18 months. So first of all, who we are. We're a fintech. We're robo-advisors. It's kind of a new emerging field. So we're FCA regulated, and we provide financial advice primarily around pensions, retirement, investments. We do have some financial advisors. We've got a couple of them we keep in the cupboard. But basically, we're automating it all. So we're putting all of that into code, and we keep them on board to make sure that we're doing it right. The great thing about working in an FCA-regulated environment is that we have lots of regulations to deal with, and compliance, and audits, and risk committees. It's great fun. We also don't have a lot of traffic yet, so we don't have scaling problems that you might be trying to solve with kube. But we do actually have some really big customers, or at least they're just signing contracts at the moment, which means we've got more audits and more compliance questions. But we're actually finding kube's really helpful in this. We are also hiring. So about 2 years back, we had a pretty standard LAMP stack. It was, unfortunately, it's running Mongo. But other than that, it's pretty standard. Development was taking a really long time to turn around code changes. The code base was pretty complex. You could argue it was just a really big if statement. But when you're trying to encode, it still is a really big if statement. When you're trying to encode, what pension should I take, how much should I invest, there's actually an awful lot of choices now. I think somebody worked out we've got more permutations than there are stars in the universe. So it's a complex code base, and being in a monolith, that wasn't easy to work with. We did, I think in 2016, we had 15 releases that year. We actually had 8 releases, and then 7 very soon after fixes for those 8. It was all right. It wasn't a pretty sight on the whole. But the main point, it was complex. It was a difficult thing to work with. So about 18 months back, it was actually just before I started there, we hired a consultancy company who actually kind of came in and got embedded in the business, and they're effectively, it was a CTO and a couple of guys, and they were given the chance to basically kickstart engineering. And what would anyone do at the moment if they're given a chance to kickstart engineering? You need microservices and containers and Kubernetes, and so we adopted micro-kubetainers. All right, complexity. The argument about microservices is complexity is moved out of the apps. And it is. The apps are much more simple. You can reason with them easily. Devs are coding them. We've had a dev start this week, and he was coding and contributing by the end of the day. But the system as a whole is still really complex. If you've got microservices, you've not lost complexity, you've just moved it somewhere else. And that's now moved down into the platform. But the good news is now that it's repeated complexity, so we can automate it. Kube is great. It deals a lot of complexity for us. It introduces a lot of new stuff, but it makes it really, really easy to deploy and run in scale apps. You don't have to worry about all that kind of traditional operations side of solving these problems anymore. Kube's done it all for you. In some ways, kind of the hello world of Kubernetes is deploying an app and getting it published live. It takes minutes. It's a little bit too easy, really. We've also found that running Kubernetes, that we're kind of having to relearn everything we've spent the last 10 years learning as Linux admins. It's all in there somewhere, but it's all been hidden away. There's another abstraction layer hiding everything. So, yeah, Kube is really easy. It's really easy to get stuff deployed. It's also really easy to get deployed itself. I don't know if anyone's tried they've kind of end of life now, but Kube Up was basically a shell script. You curl it, you pipe to bash. 20 minutes later, you've got a kube cluster running. 18 months ago, that's exactly what we did. 3 times. Test, development, production. And then the guys that did it turned around and said, there you go, Kube's done. We've got a live platform. We spent the last 18 months fixing that. And we found that Kube is still bleeding edge. It's great, but it's evolving really fast. There are major releases of Kube every 3 months. So you've got to get used to rebuilding your Kube clusters, partly because you're trying to learn more, partly because you're trying to figure out things like DR. So we've now got to the point where we can build a new Kube cluster. We did this in one of our company meetings. We deployed a Kube cluster into Singapore and got our apps running from it in our live environment in about 20 minutes. But you just get into the habit of rebuilding Kube. It's something that's kind of part of normal life now. But to be able to do that, you've got to have infrastructure pipeline ready. So get infrastructure pipeline before you let devs anywhere near Kube. Be familiar with rebuilding Kube. Ideally, do Kube the hard way. So Kelsey Hightower's put together some kind of great instructions on, don't just go and get a Kube upscript or COPS. Go and build Kube piece by piece. We haven't, but we've kind of done it the reverse way, and we've spent 18 months learning the pain of it. And we are going to do a hack day within our platform chapter, go and do Kube the hard way, because there is always more to learn about it. So don't take a shortcut with Kube. Having said that, if you're going to use Kube and you don't need to run it yourself, just go and use one of the hosted ones. Both AWS and Google are both offering hosted Kube. You can get it pretty much anywhere now. Unless you really need to run it yourself, save yourself a lot of trouble. Make it somebody else's problem. The compliance, the regulations, we actually have to run our own pretty much. We're doing this inside AWS. And the customers we're using are like, wow, really? You're in cloud? That's crazy. So we've kind of got to run it ourselves just because that's scary enough for them. We've decided to run it in AWS. We were already using AWS. We had some S3 buckets in AWS. That was it. And somebody said, well, let's build it in AWS because that's what we're using. Given a choice, do it in GCE. You're a first-class citizen in Google. If you do it in AWS, it will work. It's all fine, but there are lots of little problems you have to solve along the way, and it's constantly little problems you're dealing with. And you kind of read through through Slack channels and through the forums, and you go, oh, this problem doesn't exist in GCE. We should have just done it there. Make sure your delivery pipeline is sorted out. Again, it's really, really easy to deploy into Kube. It's too easy. Within like half an hour, you can have 50 apps deployed in there, and you've got no idea what you've got deployed in Kube anymore. But it's fine because devs are charging ahead and doing more. There are ways of kind of managing what's going on inside Kube. We've taken the approach of have everything defined outside Kube and just kind of drip feed it the bits it needs to know. So we maintain cluster state away from Kube. There are ways of recovering it now. It's certainly improved from where we were. Helm is a lot more available now and a lot more kind of mature than it was 18 months ago. We touched on it briefly, but decided not to use it. We've actually ended up kind of taking the approach, we're running lots and lots of microservices. They're basically all the same. They've just got a bit of config. They need to know some secrets. Secrets in Kube are awful, by the way, but I'll come back to that. But we're passing the same information. We quickly figured out that we could define the metadata for a service inside JSON, and we put that into Git. The really great thing about us putting that information into Git is that we actually we can code review all of the changes in all of our release. And more importantly, we can get the risk and compliance teams to approve our changes. And they just have to look at a really short page of, well, all right, it's still JSON, but at least they can basically understand it. But it means we can go and do things like rebuild a Kube cluster without any concern. We don't worry about things being deleted. Keep your config away from Kube. Keep your state out of it. Actually, we reflect that in terms of our data stores. We also don't store persistent data in Kube at the moment. We're kind of getting there. So we've kind of built our own system with JSON and Git. We then push that into a console KV store, and then we use console template, and of course Bash, because Bash is brilliant. And we use that to feed Kube. As I say, Helm's out there is much more mature, but if anyone's interested in what we're using it, we're kind of happy to share this code. We're trying to open source it. If you're interested, get in touch afterwards, and I can share that with you. So the other things we found about kube, again, it solves everything for you, but it's kind of re-implementing everything that you've already got at your infrastructure layer. There's at least 2 network layers going on inside kube that you've got no awareness of outside. And understanding all of this is really important. Your firewalls and your security groups you spent a long time setting up outside kube are basically worthless again. They control the perimeter access, but you no longer have any control around what services can talk to what. We're running our kube clusters multi-tenants. We've got really big insurance companies and banks running side by side on the same infrastructure in the same cluster. They want to see some guarantees that their traffic is isolated, that it is secure. Fortunately, kube now offers a lot of tools around this. So network policy is something that's available in kube. You need something to implement it for you. And we're using a component called Weave, which basically is a CNI network plugin. We didn't choose Weave, it just came free with COPS, which is the build tool that we're using for kube. But it's a pretty good solution. We've really grown to love it. The great thing is you get lots of choice about what you plug into kube. There are lots of other network providers, but we've just kind of gone with what was there. We don't know enough about it to have an opinion on using something else. But we have spent the time to learn it, or at least we've done it the hard way and found out the problems. So Weave is great because it allows you to implement network policy inside kube, which is basically like security groups again, but you can actually mark up, you can tag your apps with specific tags. So you can say, well, this app can talk to this one. We use it to isolate the namespaces, so each namespace is now a secure area. So we've really come to love that. But again, really try and understand what's going on inside kube. The number of times we've had a kube cluster fail, and we're really kind of down to first principles to try and figure out, well, kube's not telling me what's wrong. But from my old days before I was playing with kube, I knew this kind of problem was a network issue or something. So we've learned a lot the hard way, but it really does pay off if you understand what kube is doing. There's actually a lot of really good documentation around kube, so spend a bit of time reading the docs from the kube project on how it works. It does help. I want to touch on what we call security hygiene. Again, FCA regulated, everyone asks about our security, our patch process. Auditors love things being patched. I don't know how often, when I was at an old ad company, our patch cycle, what patch cycle? We didn't have a patch cycle. Oh, there's a bug, all right, it'll get picked up next year. We're patching things frequently now, I think there are more problems to be patched these days. It feels like there's a lot more patches coming out, particularly around Linux at the moment. But it's actually a damn sight easier having a schedule. When you don't have to worry about the delivery of your apps, about their availability and their uptime, you can just patch hosts. You shoot it in the middle of the day, it doesn't matter. It's all dealt with. Kube is really great for these kind of old operations problems. It's just solved all of it for you. The only problem is we've now got a whole new layer of things to patch. So all of our containers need patching as well. And it's actually much harder because you don't know really what's inside the container. Or has a vulnerability popped up that's on that. So we're trying to solve this at the moment. And this is clearly a bit of an industry problem at the moment. So I don't know who saw the Docker talk last month. There are solutions coming out. CoreOS offer key.io, which is a hosted repository. They've also open sourced the tool behind that called Claire, which is a bit that actually does the work. And Docker are also starting to offer their own container scanning solution. But keeping on top of the vulnerabilities inside your containers is now a really important problem. Because there might not be a vulnerability today, but one might pop up that all of your containers are exposed to. So kind of get on top of the patching, but again, kube makes it pretty easy because you can just roll things out and it deals with the availability side of things. We've got to the point now where we're always patching. There is always some patch activity going on in our system. We've brought it down to weekly because it was a little bit aggressive doing it daily, but we build a new reference packer image for the kube hosts each week. And then we have a Lambda function that just goes and finds the oldest kube host in the cluster. It shoots it, the ASG brings in the new host and builds it up. So patching is just kind of something that happens in the background. We tried doing it by hand. It took us about a month to get it all done, particularly all containers, and then up pops a new task of go and patch your host. So just automate it away. When I first wrote this, I kind of got right the way through, and I thought I actually haven't covered any of the problems that we really found that I wanted to kind of talk about. So I'll quickly kind of go through some of these. So I touched on AWS being a bit of a pain. Persistent storage in Kube and AWS, they just don't play nicely. Kube, you can tell Kube where to run pods and how to run them. But the way an EBS volume is allocated in Kube, or in AWS, sorry, it will allocate it to a host. It can't do it quickly enough for Kube to keep up. So you put some persistent volume on an EBS volume, your pod gets shot, it pops up on another host. The storage doesn't get to the new host before the pod does, and you just kind of sit there in this death loop of, I can't run the pod because my storage isn't there. So EBS doesn't work well for persistent data inside Kube. There is also EFS, so you can use an EFS volume that is anywhere. The problem with EFS is unless you've got terabytes on there, you run out of burst credits. So you can either have enough performance or the storage in the right place, but you can't have both. We even found this just with standard disks. So Kube is actually really hungry in terms of I/O. And our Kube hosts, we were building with just standard EBS disks. And what we tended to find was after about a week, a host would just go shitty. It would just stop working properly. There was nothing really telling us what the matter was until we went into CloudWatch metrics and found out that some random volume, because we don't know which volumes are really which hosts. We don't worry about tracking that because it doesn't matter. But it turns out one of them's run out of EBS burst credits. So we now have to use provision BIOS. We also find this problem in Kube that if something starts going wrong, then it cascades across the whole cluster. We think this is a capacity issue. We're pretty sure it's a capacity issue, but we want to solve it without just throwing more capacity at it. Again, I think the bit that's really scared our management is that when they said, well, you're moving from this LAMP stack, and that's costing you like, it's $1,000 a month on rack space. We'll put it on Kube. Yeah, we're $8,000 a month now. All right, it's a bit bigger, but it's not cheap to fix things. It will cost more. There's a lot more going on in it. There's a lot more demand. You get a lot more from it, but we don't want to just throw resource at it. We want to try and fix the problems. DU-S is like the death knell for us. There's some process in Kube where it tries to work out how much space you got allocated, and DU-S brings the bloody system down. It spends so much time just trying to scan the disk that you run out of I/O. A little bit on the container. So I've spent a lot of time working with JVM apps. No one likes Java anymore. It's too old-fashioned. But it's got really good instrumentation. So from an ops perspective, you know what the damn thing's doing. Node isn't there yet. Node is, developers love it. I still have no idea what the damn thing's doing. I'm really looking forward to getting some more better visibility on it. I'm looking forward to the next talk. I'm hoping the open tracing might give us more view. But Node is not great from an ops perspective, at least. We've also found this really odd problem that it takes a long time to get pods deployed onto the host. We think this might be a problem to do with AWS ECR, so where we store the containers. But we've now got to the point where the slowest point in our test pipeline, our delivery pipeline, is actually getting the pod down onto Kube. That can take like 5-6 minutes. We've got the tests running 3 or 4. It's not been enough of a problem yet for us to try something else, but it's the back of our minds. We've also found out problems with IP exhaustion. So again, I touched on Weave. We've grown to love Weave, but it's also hurt us several times. Because we're patching hosts a lot of the time, what we're finding, and this is due to a bug in Weave that I think is now fixed and is getting rolled out, we have like a 2 million IP address pool to allocate to pod containers. Each time you lose a host, you lose a chunk of that IP pool. And it took us a long time to find out the reason why the clusters stopped working is because it's run out of DHCP addresses, basically. So it is still bleeding edge. There's still a lot of problems in there to be fixed. One that's just been fixed. Again, AWS, it will deal with all of the, Kube will deal with all of the AWS ELB policies for you. But the default AWS ELB policy enables TLS1 and all sorts of nasty stuff. There was no way to fix that in Kube. you would go and fix it by hand to get through all your PCI scans, and then Kube would roll it back to this insecure policy. They've just fixed that in 1.9, so you can now specify policy. I'm going to run through monitoring really quickly. So if anyone's running Kube, do they recognize this dashboard? So it's kind of like the standard Kubernetes Prometheus dashboard. Loads of metrics on there, and none of it tells me anything. We just don't know what's going on inside Kube. It's really easy to get stuff onto it. It's really difficult to know what's happening. I'm waiting for a sales from Outlier at some point. We've also found, again, Kube is great because it's declarative. Saying, right, go in, I want this to be running. And Kube is great. It says, yeah, okay, I've acknowledged your request. Okay, is it going to happen? And so the devs go, I've done all these deployments and it's not working. So we've kind of written our own dashboard tool that tells us what we've actually got running compared to, well, it doesn't tell us what Kube thinks should be running, but this is our truth. Kube is not our source of truth for it. Our own dashboard is our source of truth. So, like Puppet, it will only tell you what you've asked for. This is just an example of that visibility. So this is just response times on some of our services, and we've got these little red dots where they stop responding. None of our monitoring, except this, shows that. There's no indication there's anything wrong anywhere. Again, the open tracing, I'm really looking forward to hearing, because maybe that will give us some clue into what's going on. But having spent years building up monitoring tools around ELK and I want to say Nagios. We've actually made a bit of an effort not to use Nagios, but there's not a day that goes past where I don't think I could have answered this in 10 minutes in Nagios. Yeah, we still don't have the visibility we want to with Kube, so there's a big kind of operations hole with Kube that we're still finding. So we've gone through a lot of effort. We've gone through a lot of cost to move away from this LAMP monolith onto our micro-kubetainers. Are we actually any better off? The platform is way more complex, but as an ops team, it's great. It's really interesting. We're all happy. It's great fun. Generally, techies love the stack. The whole microservices, Node, Mongo. Devs love the stack, so there's a lot of interest. We've got a very happy team. We've got a very happy engineering team because they love the tools they're working with. Bizarrely, auditors seem pretty pleased with the whole system as well. Despite the fact that we're on cloud and they're all terrified of cloud, they actually seem to like this extra layer of obfuscation on top of it, partly because we've got all the tracking, and partly because it's self-healing elastic and it's just magic and it just fixes everything. So actually we're getting a lot of approval from the compliance teams. The bottom line is code is quicker to develop because of the microservices. The time to deliver is smaller, so the business is benefiting. It is costing a lot more. But in balance, yeah, Kube and micro-kubetainers has paid off. It's working better for us. So there's problems, but it's better.